Hi, Gio, and welcome to our unit of area. Today is just going to be an introduction piece. We've dealt with rectangles before, so I think it'll be a nice transition to this idea of e-learning. So let's just talk about our rectangle, things that we know about it. In a rectangle, we know that those opposite sides are congruent, right? And we have right angles in those corners. We've dealt with the area of a rectangle before. You've probably dealt with it before in middle school. So when we're finding the area of the shape, which is, again, that whole area on the inside, we just use our base and our height to multiply those together to find that area. The base is typically in that rectangle, one of our sides, the horizontal one, and then our height, that vertical one, going from opposite side to opposite side. Our perimeter just deals with all four of these sides, right, being added together. And again, to find that perimeter, we just have to add up all those sides. In this example, we do not know the lengths, right? We have no numbers associated with it. So we just add up our bases, add up our heights, and then to simplify, 2b plus 2h. Our units for area are units squared because we're multiplying perhaps inches by inches, creating that inches squared. For a perimeter, our units are just singular because really we're just adding each of those sides and then combining like terms to create units. So we're going to go through a couple examples together of involving these formulas, and then I'm going to have you guys try a couple examples on your own independently. So looking at this combined figure, we're starting with a hopefully pretty straightforward one right off the bat. I'm going to start with the perimeter, right, which is the distance around the outside of this combined shape. And they're seemingly looking like rectangles. Right now I know that length at the bottom, right, is 42. I have a double tick mark to represent that vertical length, which I don't know, which I'll find. How about I assign it as x? Then I have that other length of 22, which is great. I have another vertical length, which is assigned with that double tick mark. I'll assign that as x. I'm going to have to find this other horizontal length on the top, and then I'm given that 34. So those are all the side lengths that I need in order to find the perimeter of the shape. So I'm going to start with these vertical lengths of x in order to determine those two side lengths. Looking directly opposite to that vertical length of 34, I know I have two congruent marks that make up that whole opposite side. So I can split that 34 into two congruent parts of 17 and 17. And then I need to figure out this additional horizontal length at the very, very top. I'll look to that opposite side of 42. I know the distance from here to here is 22. I could subtract that whole length of 42 to find 20 as this length of that horizontal length on the top. So to find my perimeter, I'm just adding up all those side lengths together. Plus 17, plus 17, plus 22, plus 20, 22 plus 17 plus... which I get 152 for the perimeter of the shape. The area, again, is that area inside of our figure. What I like to do is to create two different shapes, right? So my top figure is a rectangle. I know that because of that right angle in the corner, right? Same thing with that bottom figure with right angle in the corner. So to find the area, I'm talking about base times height of the top and then base times height of that bottom rectangle. So I have 20 by 17. Okay, 340, great. And then I have that base of 42 times that height of 17. Oh boy, I need my calculator for this. And I get 714, which I add those two together. And I get that area of 1,054 meters squared. And I remember to change my units for perimeter to just meters. Cool. Area perimeter of this combined solid, dealing with two of our rectangles. In our next example, we're going to deal with our perimeter and area of a rectangle yet again. So I'm going to create that figure, that rectangle, just because we don't have that visual. With that rectangle, I have a diagonal of 13. So let's create that diagonal, label that length as 13, and then I have a width of 5. So as I pause and look at this a little bit closer, I know that in order to find my perimeter, I need all of those lengths on the outside. That diagonal doesn't help us with the perimeter unless we apply it to find one of our sides. So I'm just going to focus in on one of those right triangles and apply Pythagorean theorem to it. So I have my 5 squared plus x squared equals 13 squared. Those of us that love our families, which is all of us, right, we are able to use that 5, 12, 13 family to find that length of 12, or Pythagorean theorem, your choice. Then we can add up all of those sides together to find that perimeter. So I'm going to take my 5 plus my 12 plus my 12 plus my 5 to create that perimeter of 34 inches. My area, I'm just finding that base times height. My base is 5, my height is 12, or vice versa, really at this point. Multiply those two together, and I get that area of 60 inches squared. Again, double checking those units, making sure we're feeling pretty good with that. And then our last example deals with a little application question. You might have remembered these questions in algebra, some border questions. So yeah, let's kind of dive into this. We are planning a deck along the perimeter of a rectangular pool. Sounds kind of nice about now. The pool measures 18 feet by 12 feet. So I'm going to label those lengths, right? I have my length of 18 for the pool, and then that 12 feet. Sounds like a small pool, to be honest. Anyways, the deck is going to be 8 feet wide. I'm going to label this in a white pen. Hopefully we can see that a little bit more clearly. So the width of that deck around the outside of that pool, 8, right? 8 for all of these, 8. Some chaos going on here, 8, right? Dealing with that whole width of the deck around the outside. We want to figure out just the area of the deck, right? Which is that wooden portion on the outside. Looks like some nice hardwood floors. So we're going to find the area of the total, right? This whole figure here using our base and our height. And then because we don't want to put hardwood, right, or that deck over the pool, we're going to take out the area of the pool on the inside to figure out just that portion surrounding the outside. So to figure out what the base and what the height is of this pool, right, I'm going to start with the height. I have this measure of 12, but then additionally I have this deck on top and this deck below. So I'll take my 8, right, of the deck, I'll take my 12 of the pool, and then another 8 to figure out that length of that whole side. I'll do the same thing to figure out that other whole length. 8, I have 18, and then I have 8, which I'll add all together to create that measure of 34, right? So I'll find my area of the total by multiplying my 28 by 34 feet. Okay, multiply those things together, and I get 952 feet squared. Again, that issue is we don't want the area of the pool, right? We don't want that pool covered, so I'm going to subtract the area of the pool. We're already given the measurements of that pool, that 18 by 12. So I'll multiply those two things together, and that's what I'm subtracting from the total. So I multiply, obviously, those two lengths together and do a little subtraction, and I get a total area of the deck of 736 feet squared. Just leaves us for a lot of area for grilling, I guess. Okay, so those are a couple examples that we went through together. If you go to the next page, you're gonna do some practice problems involving some combining of some rectangles, finding the area, using some Pythag to find the area of the rectangle. And I did incorporate an area of the triangle just for us to start making some conclusions about these shapes. And maybe we can even apply a formula that we might remember about our area of the triangle. So go ahead and pause the video and try the next 3 examples. Once you've tried those 3 examples, you can unpause the video and check your solutions that way. Thanks again for your flexibility and enjoy. So these are our answers to the practice problems. For this first example, I created the bigger rectangle, right, this whole figure to be the total, and then subtracted the areas that we didn't need on the outside. You could also break it into 1, 2, 3, 4 different rectangles and add those areas together. I just thought this was the most efficient way to do it. Again, no wrong method per se, but we should get that consistent area of 84 or 82 feet squared. And then B ends up being a little bit trickier, especially for our people that haven't been in chem yet, right, to deal with that sig fig idea, to take that 82, that erased for some reason, 82 feet squared, and then multiply it by our conversion rate, right, 1 yard for 3 feet, 1 yard for 3 feet. Your feet squared, right, needs 2 of those feet in the denominator in order for those units to cancel. And then we still have those yard by yard squareds in the numerator. So you'll take that 82 over 9, right, there's a decimal in there, but we want to keep it as that exact answer until the very, very end. And then we'll multiply it by the cost per yard squared, and we'll get that $38.63 as that cost. And again, with money, we do deal to the nearest hundredth, so we would round, in this case, just to 63. And then for the second example, we're given that diagonal and we're given one of the sides. So we could use Pythag to solve for that missing length, which thankfully we do get that whole length of 8. And then we could just apply our base times height or length times width to the area of that rectangle. If you got 3, awesome. A little bit trickier. We do have an isosceles triangle, so we're able to drop down that height, which is what we need in order to find the area of that. Again, this is a little bit more of a challenging question. So if you got portions of it or almost there, that's awesome. Because we haven't learned per se the formula for your area of the triangle, 1/2 base times height. So we would drop down that height, use Pythag to solve for that missing height of 2 root 7, and then multiply that 2 root 7 by our 12 by that 1/2. So those are the answers. There are some good examples for us to go through.